Hello everyone, I'm Pooja and I'm going to explain you in detail chemical properties of metals and non-metals. So let's begin. So we are going to understand the chemical properties of metals and non-metal. Now first property is reaction of metal with oxygen or reaction of metal with air. Now when metal react with oxygen, they form metal oxide. So this is the general equation irrespective of any metal. All metal when they react with oxygen or air, they'll form metal oxide. Let us apply this to frame the equations. When magnesium react with oxygen, from magnesium oxide. For potassium react with oxygen, it form potassium oxide. And the formula of potassium oxide is K2O, and you have to write always the balanced equation. Now if we see the iron react with oxygen in the presence of water, or you can say water, if water is present in the air, that means it's a moist air. So iron reacts with oxygen in presence of moisture, it forms the iron oxide, which in common word we say rust. You must have seen this rust very commonly in your homes or outside in the metallic parts where there is iron and there is moisture. The rust is likely to be formed there and it is reddish brown in color. Similarly, for the copper, there is corrosion like rust if the moisture is there. So copper metal reacts with water, carbon dioxide, oxygen, forming copper hydroxide and copper carbonate together. This copper hydroxide and carbonate forms a green color coating, which we say it's a copper corrosion or rust of the copper. So second thing is that now these metal oxides, how we will identify, how we will investigate the nature of metallic oxide. So first thing, the metal oxide which is formed are always basic in nature. But how you are going to identify the basic nature? As in my video about acids and bases and indicators, I explained you how can we identify the acid and bases using indicator. Similarly, these basic oxides or metallic oxides which are basic in nature, we can identify using the litmus paper. So what we have to do, we can take the metal oxide, dissolve in the water, and you can add the litmus paper. If the color changes from red to blue, that means it's basic in nature. So let us see for this reaction where the magnesium is reacting with oxygen. Now magnesium burns with a dazzling fire. So it is a white magnesium oxide is formed, so it's white powder. Now that white powder you can dissolve in the water. Now once you dissolve in the water, you can add the red colored litmus paper, and that red color paper will change into the blue color. That shows the magnesium oxide which was added to the water is basic in nature. Similarly, we can apply it to the rust. You can take the rust and add to the water, and rust is not completely soluble, so there will be a suspension form. And you can add the red litmus paper. You can see this is turned into the blue color litmus paper. That shows these metallic oxides are basic in nature. Now let's move on to the non-metals. How the way non-metals react differently with oxygen. Now non-metal, when they react with oxygen, they form non-metal oxide. Like example, if carbon react with oxygen, form carbon dioxide. If sulfur react with oxygen, form sulfur dioxide. But the reactivity differs from each other. Like phosphorus, it's highly reactive with oxygen. It immediately, when it is exposed to the air, it catches fire immediately. So it is always stored in water. Now why it is stored in water, that I'll explain in the next property. Because it doesn't react with water. So like the different reactivity of the metals depends upon the spontaneity of the reaction. And some non-metals react slowly. Same is the case with the metals also. Metals react differently with oxygen. That depends upon their reactivity. And for reactivity, you can refer to the reactivity series. Now, what will be the nature of non-metal oxide? Non-metal oxide are opposite of metal oxide. Metal oxide were basic in nature. Now, non-metal oxides are acidic in nature. Now again, how will you identify? The same way we did for metal oxide. You can take the any oxide, dissolve in water, and then you can test with the litmus paper. Like here you can see the burning of sulfur. Now sulfur dioxide is a gas produced, so we have to test in a closed jar. You can take the deflagrating spoon and then you can add the water, and then after that you can, once the solution is formed, sulfur dioxide get dissolved in the water, you can add this, you can see the blue litmus paper, it is turning into red color. So that shows that sulfur dioxide, which is formed by reaction of sulfur between oxygen, it is acidic in nature. And you can see the reaction here as well. Sulfur dioxide plus water form H2SO3. The name of the acid is sulfurous acid. So acid is formed. It's very simple. An acid is formed. That means it's acidic in nature. Similarly, carbon dioxide form H2CO3, which is carbonic acid. An acid test always change the blue litmus paper to red color. So that is how we can identify in the lab, and they all are acidic in nature. Let's move to the next property, reaction of metals with water. Now how metals are going to react with water? Again, all these reactivity of metals depend upon their order of reactivity. For that you should know the reactivity series, and for reactivity series, the reaction between metals, you can refer my other video which is on the displacement reactions. So metal plus water always form the metal hydroxide. So irrespective of any metal. Now let's see some reactions. Sodium plus water form NaOH, and there is always a hydrogen gas is evolved in the reaction. So this is the characteristic reaction of metals with water. A metal hydroxide plus hydrogen gas is released, and the reaction is highly vigorous, and a lot of energy is released in the reaction. So it's an exothermic reaction. Now once we can see one more example, calcium plus water, calcium hydroxide and hydrogen gas. But how do we test the hydrogen gas? How do we identify the gas evolve as hydrogen? That we have to test for hydrogen gas. Now hydrogen gas test is, you can take the hydrogen gas test. You can take the burning splinter or burning matchstick to the mouth of the test tube where you have the reaction mixture, and the gas burns, hydrogen gas burns with a pop sound. So there will be a pop sound. That is the test for hydrogen gas. Now you can see here these metal reactivity, as I have already told you, this reactivity depends upon their order of reactivity. In the order of reactivity, some metals are highly reactive, some are moderate, some metals doesn't react with water. So the metals which are very highly reactive with water at room temperature, like sodium, potassium, calcium, they are always stored in kerosene, as they are not reacting with the kerosene. So they are always stored so that they should not come in the contact with water or moisture at any time. They can catch fire. So that's why they are stored in kerosene. While I just showed you the rust. It's a very slow process. So iron reacts with water slowly. So that is how the reactivity of different metals differ from each other. Now let's move on to the next one, the non-metals reaction with water. So what is the equation form? Non-metals do not react at all with water. So irrespective of any non-metal, they don't react. That's why I explained you the phosphorus, which is very, very spontaneous, react with oxygen. It is stored in water, because non-metals, they don't react with water. So next okay. So this I already explained you in the previous slide. Next is metal reaction with acid. They form salt and hydrogen. Now again, the salt and hydrogen we can write like, see, the zinc react with hydrogen chloride. So zinc chloride is formed plus hydrogen. If we take sulfuric acid, zinc sulfate is formed. So whatever the acid we are taking, corresponding salt will form. If we are taking hydrochloric acid, the metal chloride will form. If we are taking sulfuric acid, metal sulfate will form. If we are taking nitric acid, metal nitrate will form. And all these reactions, there will be an evolution of hydrogen gas. And again, you can test the hydrogen gas with a burning splinter or burning matchstick. It burns with a pop sound that shows this is hydrogen gas. Now there are other example, magnesium plus HCl, iron plus H2SO4, all these form salt plus hydrogen gas. Now this one, if the metals are reacting with the acids, how come some metals don't react with the acids at all? But how do you identify which metals are going to react spontaneously, which metals are going to react slowly, or which metals are not going to react at all? As I already told you, this depends upon the reactivity series. Now this you can see here in this reactivity series, it is arranged in the order of decreasing reactivity. The metal at the top, potassium, is the most reactive. The metal at the bottom, platinum, is the least reactive. So if we apply this table to identify whether this metal will react with an acid and all acids, they contain hydrogen ion. So the metal placed above the hydrogen, they will react with an acid, but metal below the hydrogen, they are not going to react with an acid. So if I will say silver, gold, platinum, there will be no reaction at all if you add acid to them. But if you add acid to the metals above the hydrogen, whether it is iron, zinc, aluminium, magnesium, they are going to react and they are going to form the corresponding salt with the release of hydrogen gas. Now you can see here the copper. If I will ask you, the copper will not react with the dilute acids, but there is an exception. If it's concentrate sulfuric acid, it can react. So copper does not usually react with dilute acid, but on adding the concentrate acid, it can react easily with the sulfuric acid. So this is one exception. Usually when it asks, the copper is copper is the metal which doesn't react with dilute acid. Now non-metals, they don't react with the acids at all. So there is no reaction. Now this one, the last, is the metal reaction with bases. Now metal when react with base, as you know, metals, any metal you can choose any base like NaOH, KOH, it will form salt, and again there will be a release of hydrogen gas. Let us see in some equations. But this bases, there's the salt, the formula is complex, so you don't have to go in the detail for the salt formula. You just have to focus on the basic equations. Then the displacement reaction. Now what is displacement reaction? This you can refer to my displacement reaction video. When a more reactive metal displaces the less reactive metals from its salt solution. Now metal salt, it can be in any form. I told it can be chloride, nitrate, sulfate. So look at this example now. Zinc reacts with copper sulfate solution. It forms zinc sulfate and copper. But whether this reaction will take place or not, how will you identify this reaction will take place? You have to refer to again the reactivity series here. Now we can see zinc is above copper. So zinc is more reactive than copper. So what can happen? Zinc can displace copper easily from its solution. So zinc will kick off copper and it will combine with the sulfate, leaving copper behind. So when you have to write down the observation, yes, the reaction will take place, and zinc metal, which is silvery white color, copper sulfate will be blue color solution, and you can see what will be the product, what will you observe in the reaction if you are carrying out this reaction in the lab. Zinc sulfate, the solution will turn into the zinc sulfate, which is colorless, and at the bottom of the test tube or the beaker, a red brown color copper metal will be formed, because this is how the reaction is taking place. But if there is reaction is given, if you add copper in zinc sulfate solution, so there will be no reaction. Why? Because copper is less reactive than zinc, so it won't be able to displace zinc from its salt solution. More detail you can get in my other video with the other examples. So this is how the displacement reaction, you can identify whether this metal will displace the other metal from its salt solution or not. Or if you are doing in the lab, you can see here, this is one more example. You can take the magnesium strip, and this is the copper sulfate solution, which is blue in color. Now what you will observe after some time, that magnesium will dissolve in the solution, and the blue solution will change into the colorless solution, and reddish brown copper, you can see it is formed. That is, again you can explain using the reactivity series. As magnesium is more reactive, so it displaces the copper ion from the blue solution, copper sulfate solution, and the copper metal is formed, which is settled at the bottom of the beaker or test tube, wherever you are doing the reaction. So this is how you can identify or investigate experimentally these displacement reaction. So I hope you understood all the videos, all the explanation of different metal and non-metal chemical properties. If there is any doubt or anything, you can post in the comment section. And please like and subscribe and share. Thank you.